Okay, welcome back everybody. All right, so we're ready to do our lab for this week. Our lab is called the half-life of pentium. So if you take a look at your handout, be sure that you've got that ready so you can fill it out as you're going along with us in our lab video. Miss Ursary and I will get the data ready for you to record. So all radioactive matter, as you've learned through your notes, all radioactive matter will go through nuclear decay. The radioactive elements then become non-radioactive over time, given enough time. Each radioactive element has a unique rate of decay that's called the half-life, and it is the average time that it takes for half of the atoms in a radioactive sample to turn into new atoms. This lab will give you a model to learn more about the concept of half-life. Okay, so we have here 100 pennies placed in this paper plate. They're arranged so that they are all heads up. Okay, notice that on your data table, the first entry is time equals 0 seconds. So you have, as you can see in the plate, they're all heads up. Heads up is going to represent undecayed radioactive atoms. So we have 0 decayed, so that would mean that we have 100 radioactive atoms remaining. So you'll record a 0 here and a 100 on radioactive atoms remaining. Okay, now we're going to have it go through 3 seconds of radioactive decay. I'm going to take a plate, place it over the other one, and I am going to shake it and try to not lose any, because I don't have a box where you guys can see with the camera. Okay, here we go. Okay, now we're going to sort. Miss Ursary is going to help me pull out the pennies that are tails up. The pennies that are tails up are going to represent the atoms that have undergone radioactive decay and have turned into a different atom. So we're going to pull those out to the side for you. Notice that we're being careful to not flip any of the pennies. We want to get, no, almost hit on that one. We want to get only the ones that have flipped during that 3 second of radioactive decay. I see a couple over here. Okay, now we're going to count how many of these pennies have undergone radioactive decay. And these are pennies that have now turned into a new element.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39.
Okay, very good. Thank you, Miss Ursary.
You're going to write 39 atoms under 3 seconds that have decayed. And then you will subtract that from 100 and write how many radioactive atoms remaining. And we're not going to tell you that because we think you can do that yourselves. So now we're going to move to the next one and do this again for another 3 seconds.
Okay, so now we see our sample. And how many decayed was that, Miss Ursary? It was 39. Okay, so another 3 seconds. Get a firm grip on this so I don't lose it. Okay, now let's see what we have. Here's one right here. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, and 33. Okay, so for the second 3-second interval, which would be a total time of 6 seconds on your data table, you're going to record 33 atoms have decayed, and then do the subtraction.
Yes, and make sure when you do the subtraction, you're subtracting it from the radioactive atoms remaining. Don't do it from the 100. Do it from the one that was at 3 that were remaining. Then you'll subtract 33, and that's what you're going to write here under radioactive atoms remaining. And now we're going to do it for another 3 seconds.
Okay, so here's our radioactive sample for another 3 seconds of decay.
Okay.
Okay.
And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay. So your next entry here at a total of 9 seconds, you will have 12 atoms decayed. And then, as Ms. Ursary said, you want to your atoms, radioactive atoms remaining, you need to subtract this 12 from the previous remaining radioactive atoms. Okay. Now for our next radioactive decay. Okay.
So we have 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay. So on 12 seconds, you'll record 9 atoms decayed and then complete this one. Okay, now for our next interval.
Okay. So we have 1, 2, 3, 4.
Okay. And again, make sure everyone has time to record that data.
Okay. So we have 1, 2.
Okay, and the next interval.
And we have now 0 radioactive atoms remaining. So now you're done. Now, okay, so it says to do trial 2. So what we would like for you to do is to go ahead at home and see if you can find 100 pennies, even if you have 50 pennies. Talk to your parents, see if you can find 50 pennies, and then we want you to try this for trial 2. And then make them all heads up, and then what we want you to do in your lab handout is take the average. So Ms. Bunch, will you hand me this? Okay, so then you will take the average. So you do the exact same thing for trial. So you'll do the exact same thing for trial 2 as we did for trial 1. And then you will take the average for each column and write it right here, okay? For radioactive atoms remaining, you'll take the average. Now, make a graph of your data by plotting the average number of radioactive atoms remaining versus time. consider all parts of a complete graph. Okay, so here's the graph right here. Okay, and so when it says take the radioactive atoms remaining versus time, okay, time's going to be here and your radioactive atoms are going to be here. Okay, and so then you will graph that, and then you're going to talk about these questions right here after you graph your sample. So these questions will be based off of your actual graph. Okay, if you have any questions, please don't hesitate to ask. Miss Bunch and I hope you have a great day.
Have a good day.